Okay, welcome guys. So today let's talk about some interesting problem. Let's talk interesting problem. Okay, so before I start, I hope you guys subscribe to my channel. Okay, so you have a positive A1, A2, which are positive series. Basically, it's positive real numbers. So each number is a real, and all are positive. And you hope to, and the theorem says that there is a finite infinite integers. Right, so basically you can find infinite n, right, such that a1 plus an plus 1 divided by an less or equal to 1 plus 1 over n. Oh, sorry, should be greater than 1 plus 1 over n. Okay. Okay, so the proof. So this question is very interesting. So the proof is basically proof by contradiction. Okay, so suppose not, right? Suppose not means that there is this k, right? K belongs to n. Then for all n greater than k, you always have a1 plus an plus 1 divided by an will less than equal to 1 plus 1 n, right? Okay, so you can change it into an minus an divided by n. You just greater or equal to a1 divided by n plus 1 plus an plus 1 divided by n plus 1. I think you just write down as this, right? And then you do the expansion, so you can get this. Yeah. Okay. Right. So this gives you that ak greater or equal to k will greater or equal to a1 divided by, right? So I can plug n equals to k, right? So k plus 1 plus ak plus 1 k plus 1, right? So and this guy greater or equal to a1 divided by k plus 1. So I think the first this term fixed. And the least term we use the same, right? We change n to k plus 1, so it's greater or equal to a1 plus still k plus 2 and ak plus 2 k plus 2, right? And we can keep going, right? So finally we will prove that ak greater or equal to k will greater or equal to a1, right? And you can do m times, so that you get I from 1 to m, right? So you get k plus I 1, right? So this term plus second term is ak plus m, k plus m, right? You can keep going, right? But remember the simple calculus result as m goes to infinity, summation I from 1 to m, right? K plus m is is close to a harmonic series, right? So this will blow up to infinity, right? And ak plus m is always positive, right? Because the reason is that whenever, no matter what ak plus m converge or not, right, you always greater or equal to 0. So if you take m to infinity, then the left hand side is some finite term, right? Some finite, but the right hand side must go to infinity, right? So this is a contradiction. Okay, so yeah, this is just a simple video and prove some interesting facts. Okay, I'll see you guys in the next videos.